see some questions. For example, for this question first says that find the general solution of this equation. So as we can see here, we have given two solutions, two uh, terms in the right hand side, and first one is the polynomial term and second one is the exponential term. Now one approach would be to break it down into two differential equations. For example, like first take just the polynomial case, and secondly just take the exponential test. Then to find the uh, general solution or the complementary solution, it is easy because we solve this characteristic equation and then find these roots, and we can say that these 2 and 2 are the repeated roots. So we write c1 plus c2 times t, plus again for this minus 2 and 2, these are unequal but real roots. So c3 exponential times minus 2t plus c4 exponential times 2t. So this is the complementary function. Now we have to find the particular integral. For that, let's take this differential equation first. Then for that, as we can see, it is a polynomial form. Now one thing that you should understand in the polynomial form is, even though the term is just the t squared, we need to take all the other terms that comes after it. For example, t plus 0 times t to the power 0. We need to take this to account into the account. That's why we take a t squared plus bt plus c as this linear polynomial. Now you may be wondering, where does this t square come from? As we have seen from the cases that we have been discussing, see if 0 is not the root, then take this equation. If 0 is the root, then take this equation, x to the power k. Now k is the root of multiplicity of multiplicity. So as we can see here, it is t times k. Now what is k? K is the multiplicity. It means how many times this root has been repeated. It is 2. That's why we take the we take k is equals to 2 and multiply it to the linear combination, and suggest or suppose that this is actually the linear combination or the particular integral of the given differential equation. Now then after, we find all the differentiation, all the derivatives that are in this question. For example, we have a second derivative term, and then after we have a fourth derivative term, and we differentiate it as many times as we want. Then after, as the question suggests, then after we substitute them in the question and find the values of a, b and c, and substitute them in the solution that we have guessed. Put the values of a, b and c, then we get the solution. But one thing that we have been missing here is we split this differential equation into two differential equations. We have found the particular integral of it, and we have to find the particular integral of this exponential form also. Now this exponential form is et, right? So what was the solution that the function was suggesting? So it was saying that if it is alpha x and alpha is not the root of the auxiliary equation, then just say yx is equals to a e to the power alpha x. Now let's see. Now alpha here is 1. Is 1 a solution of this homogeneous equation? I don't think so. So if it is not, then what we can do here is just say d or a times e to the power x or e to the power t in here. Then after we again find the different derivatives that the question need. Then after we substitute them and find the solution, and from the principle of superposition of the particular integrals, we can add these two particular integrals as one and then find the solution by adding them to the complementary solution that we have found. So it is, so a lot of things are going here, so a lot of things can go wrong if you don't remember these kind of functions. So it was so I dedicated a full video, a single video of to understand these functions. Okay, now let's see another question. For example, this question. Okay, now let's see this one. So if find the general solution, and we have been given with this general solution, and we can see here that one is just 3 and another is a trigonometric function. So again is same thing that goes on. First of all, find the characteristic equation. Okay, so we found that there are complex roots and there are repeated roots. Okay, complex and repeated roots are there, so it means we find c1 of cos t plus c2 of sin t is plus minus 1. So the solution of 1 plus minus 1 plus minus I is this one, c1 cos of t plus c2 sin of t. But again this root is repeated, so we can say plus t times again c3 some another constant plus c4 sin of t. So I think you guys know what I'm doing here. Okay, now if so we have to find the solution of the particular integral. Now we can see that some constant is here and then after the trigonometric function, so we can so always remember when we are guessing or when we suppose suppose a particular integral and we have uh, either cos or sine alone in the right hand side of the differential equation, you should remember that we always put cos as well as sine while we suggest or while we suppose the particular integral for it. Okay, you should always remember that. Then after we find the successive derivatives, and then after we find the value of a, b and c. Now the tricky part here is how do we solve such large derivative of this function. This particular integral is a trigonometric ratio, so it would be easier for us to do that even though it is fourth derivative. But if it was a kind of product, for example exponential times us trigonometric is a right hand side of the non-homogeneous differential equation, it would be hard for us to find such kind of large derivative of it. So I will discuss such cases in previous video in after videos in the later videos, but it is quite important case, so you should remember that, and you should intentionally, or you should check out how do you solve such kind of questions, because it would be easier, it would be easily a good question that can come to your exams. So again coming back to the question, this is, so you find the values of a, b, c and you substitute in them, then you find the general solution of this differential equation. I hope that these videos are good, are helping you to understand this chapter better. I will definitely come with another videos, and I'll post some of the important concept. Again, we have another method also, which is called the method of variation of parameters. So thank you so much for watching this video.